Well, let's not go all the way to cylindrical coordinates. It's very simple once you have the polar coordinates, so we'll start with polar. In polar coordinates, your typical increments defined by sample point in polar coordinates, r star, theta star. Okay, so what's that mean? That means we've got, and this would just be in like an XY plane sort of, right? But it's r theta. So here's your pull, and we don't have a y here, but we'll still use rectangular coordinate system within which to think about our polar coordinates. Okay?
Because it makes it easier to draw.
Well, it just orients us a little better. If I just draw a pole, which would start at the origin and go in one direction, and then, yeah, it's a little harder when you're first thinking about it, although you've done plenty of stuff with polar coordinates, to orient yourself relative to an XY coordinate system. It's strictly unnecessary, but it's a little more abstract. So let's just start with the easy picture. Okay, so we got some point r theta, r star, theta star, right?
Yeah.
So, like up here, you know, I didn't label it, we've got the point x star, y star, z star. And of course that's implicit since I did this by projecting x star, y star, and z star. Within a delta x by delta y by delta z box. I don't want to have to write out small rectangular parallelepiped, tiny. Okay, make sense? So what do we have here? Well, there's r star, and there's theta star, right? Now, we have a delta r and a delta theta increment. Okay? And delta r is some r interval that contains r star. Okay? Because this has to be, and I say with some delta r and delta theta, yeah, but of course this point will be within the corresponding increment. So, you know, what happens? Well, you got some r increment, right? So delta r kind of gives you this. Now delta r would be in one direction, okay? Maybe it's this way, maybe it's this way, so I'm being a little loose with the notation, okay? And what's delta theta do? Well, delta theta gives you some theta increment. So here's your delta theta. I have to label it out here because it makes a figure all that big, but here's your delta theta, right? Now my question is then, if delta theta and delta r are both small, then these two radial lines here that define delta theta are nearly parallel. So these are nearly parallel. For small delta theta, right? And these two segments here are nearly straight for small delta theta. Okay, so this segment here and this segment in here, nearly straight. Okay? Also, these things all meet at right angles. So you have a right angle here, you have a right angle here, and of course it's a right angle to the arc, meaning it's a right angle to the tangent line at that point, right? Which means that what you have here is very nearly a rectangular, well, it's very nearly a rectangle. Okay? I was going to say a rectangular box, but a box would have 3 dimensions. We're just in 2. This is a rectangle. Okay? So my question is, here's R star, theta star. Here's 2 arcs that are small enough that they appear for all purposes, all practical purposes, to be straight. In other words, in every integral we're going to let these dimensions all approach 0, right? So as they approach 0, this thing gets as straight as you want it. Okay? And all these angles are right angles, so I'll just lightly draw a right angle symbol in there just to be complete, right? So my question is, what are the dimensions of this near rectangle? Okay, so figure that out.